Okay, some notes on vertex form and translating quadratics. First, we're going to figure out how to convert the quadratic equation into the vertex form. So converting a vertex, which contains an x and a y coordinate, it's also known as an h and a k value. Here's the vertex form. This is the parent function of vertex form. And parent function just means this is the generic function without any numbers plugged in yet. Okay, so the a value actually won't change. Whatever the a value was in the beginning, it's going to stay the same. The vertex, the x and y, which is also the h and k, you're going to go ahead and plug that in for the h and the k value, whatever your vertex comes out to be. Okay, so examples. Here we have the equation 2x squared plus 8x minus 1. Here's our a value, the b value, the c value, which are listed over here. If we use the vertex formula, opposite of b over 2a, and we plug those values in, we end up getting an answer of -2. So then if you want the y value, you go ahead and plug that back into the original equation, which I do right here, replacing every one of the x's. And when I work that out, I end up getting an answer of -9. So the vertex is those two answers, -2, -9, which of course is your h and your k value. So now let's go ahead and use that and convert it into vertex form, where our a value, it doesn't change. It was originally 2. It's going to stay at 2. So we plug that in. I have to put the minus sign there, and then I plug in the h value. So I notice that there's a double negative situation. Well, anytime you have that double negative situation, you're going to have to turn that into a plus sign. So if you'll notice, your h value, it's going to turn out to use the opposite sign once you plug it into that form. So if the h value is negative, you'll end up with a plus in front of it. If it were a positive, you'd end up with a minus in front of it. The k value doesn't do that, though. The k value, because there was a plus sign in the formula, when you plug it in, it maintains that same sign that it had from the coordinates. Now, as far as translating is concerned, if you're trying to identify the translation, which is basically the shift from the origin, all right? So the original x squared quadratic function would start with a vertex on the origin. Now we're trying to figure out, okay, based on this equation, where did it shift? Right, left, up, down, what did it do? Okay, so, oops, sorry about that. The h value represents your horizontal shift left to right, but you remember you're going opposite the sign, because when you plugged in that h value, it ends up with the opposite sign. So we've got to realize, oh, okay, well, if it says +2, it really meant left 2. The k value doesn't do that. The k value goes the correct direction that it says. Okay, so the k value is the vertical shift, up or down. And as I said, the shift is telling you where it's going to move from the origin. So here we see a +1. That means left 1. Remember, opposite the sign, right? This says -5, and it actually means down 5. -3, remember, go opposite the sign, so that means right 3. And +1 means up 1. And last we have a +4. Oh, I'm sorry, not last, we got 2 more. +4. We don't have a k value out here. It's just +4, so we only have a horizontal shift, left 4. And then here, there's no parentheses, so we don't have an h value. That's actually the k value. So you want to move down only. All right, so anytime you don't see the parentheses, that means that that's your k value. Down 9 is your shift.